Hello and welcome to this repair tutorial, and today we have a NAD and the model number is 304. In terms of general specifications, power output is 35 watts RMS into 2 times 8 ohm speakers. Total harmonic distortion is 0.03% over the frequency range of 20 Hz to 20 kHz. Input sensitivity for your moving magnet type input is 2.5 millivolts. Other inputs, it's 165 millivolts. At the rear of the amplifier, you could use a preamplifier output. Maximum there is 12 volts. You can connect directly a set of headphones for personal listening. Maximum impedance would be 600 ohms at 10 volts. At the rear of the amplifier, you have a switch, so you can enable or disable the soft clipping feature. And on the front panel, you will also have an LED which will illuminate when it's active. In terms of dimensions in millimeters, height is 108, width 420, and depth is 320, and the weight of the amplifier is 6.4 kilograms. And then if we just take a look from the top, as you can see, there's quite a lot of dust inside of there. The owner of the amplifier advised that he'd owned it from new, so no form of service work has ever been carried out. And this dust layer, as we referred to in many of the tutorials, is not of concern. This amplifier did not come from a damp environment, so it's just a matter of using a stiff brush and compressed air line just to clear out all of that dust, which has just fell through the vent grills on the top. And then here, when we look towards the front, you can see the individual controls. So on the left hand side, this is the volume control, then you have the balance control, and then also your bass control. You can also see that the input selection is mechanical, so there's no electronic switching here, and it doesn't have any forms of relays to select the different inputs. And then here, when we look towards the rear of the amplifier, what I've done is I've just put a circle around the links. Now, on many NAD amplifiers of this era, you will find these links in place. What it's simply doing is it's connecting the preamplification side of the amplifier directly to the power amplifier stage. Now, during the initial inspection, from what I can understand from the owner of the amplifier, and the reported issues were sort of intermittent loss of sound. And of course, that is not uncommon with any amplifier from this time period. But what I did was I just ran through a number of initial checks. So just verifying that the amplifier was working, i.e. that you had audio on both channels. What I found was that if you selected the CD input, what you had was a very, very loud 50 Hz power hum coming through. And then on greater inspection, what I found was that the actual connection where you put the screw in the rear and then lock it then onto the back panel was damaged. And then you could also see that one of the grounding pins on the CD input had broken away from the circuit board. Now, if the fixing screw hole was not damaged, then you could probably make a repair by simply connecting a piece of link wire to replace the ground connection. But because the plastic mold was damaged, the only thing you could do here was to replace that complete assembly. And you'll see that later on in the tutorial. And then here what I'm highlighting is really one of the common issues, which is age related to this amplifier. And this is associated with dry solder connections. So these are the different RCA input sockets. And what you can pick up is that there is cracking and there's also dry solder connections around the majority of these. And that is the case also for the whole of the amplifier board, but we'll sort of touch on that in a little while. So while I was resoldering all of the RCA input sockets, what I also did was to replace that damaged or broken phono/CD input RCA socket. And you can see that here. So I've just drawn a circle around it. And then here, when you look from the back of the amplifier, you can see that there's gold plating on both the phono and the CD. And then this matches the original ones as well. And then another very common issue with this amplifier, as I referred to a moment ago, is dry solder connections. So as I've said in many tutorials, you really have to take a systematic approach. So you need to really look at each one of these solder connections, and then you need to resolder each one of them in turn. It's probably going to take you quite a considerable amount of time, and as I always say, just be very careful. Make sure you don't accidentally do a solder bridge, and just verify your work. And then here on this photograph, what you can see, I've just drawn a series of yellow boxes. The reason why I've done that is that this amplifier, and I'm not too sure why the manufacturer would have done this during the production, but they basically used some glue to try and glue around the heat sinks which come and protrude through the board, which is a little bit bizarre, to be honest. the problem associated with the glue that they've used, it's the same glue that is mentioned in many repair tutorials. This glue over time will become very hard, and what it does, it becomes conductive. The problem here is that these heat sinks are connected to power transistors, both in the power supply and then also in the driver stage of the amplifier. The only good news is that the glue hadn't fully dried out. There was still some elasticity to it. But it's very, very important to remove that glue, because the last thing you want is conduction within a transistor when there shouldn't be, and this glue would have caused that issue. So it's just a case here of just using some flux remover, and then it just completely softens up the glue, and then I was able to peel it away from the circuit board. What I also did was, where the glue had covered some of the circuit board tracks, I just verified that there was no corrosion to the tracks, i.e. hadn't sort of come to a point where it was almost burning through. And then I also desoldered the transistors and then reflowed them with brand new solder as well. And then the other area which you will find where there is dry solder joints is here on the headphone socket, and there's always cracks around here. The point to emphasize is that there is switching contacts on the headphone socket, which effectively will mute the amplifier from the speaker terminal side. So resolder. And then the other thing is that while I was working on the main board, because I have to remove the back panel, what I've done is I've desoldered the soft clipping switch, and it's just a simple 2-pole slide switch. But what's very important is that you need to take it apart, and straight away what I'm showing you is really the level of oxidization on these copper terminals here, and also on the slide part of the switch. It's completely contaminated. Now, you could attempt maybe to try and just apply some switch cleaner, but in most cases it won't actually get through and clean as it's required. So what you need to take is a fiberglass pencil and then just lightly stroke across these contacts, and it will remove all of that oxidization. And then you can then use De-Oxit D5 then to coat it and then to do a final clean. So here you see the before and then after cleaning as well. So the contacts now are all very bright. And then what I do, of course, as I said, is just to apply some D5 De-Oxit, and that just provides that longevity. And then the other most common issue with this amplifier is associated with these resistors, and they are 47 kiloohm. And if you're looking for them on the circuit board, the reference numbers is R333 and R334. Now what will happen is, again, time related, these resistors just go high in value. In many cases they go open circuit. And what you'll find is that the amplifier will not complete its initialization. So the power LED, instead of after about 5 seconds and the speaker protection relay changing over and then the LED turning green, it just remains red. So it's always remaining in a protection mode. And then on the circuit board, these are the resistors here. So this is the first one, and they're quite easy to find. It's not sort of tucked away behind components. And then here, that's the left channel, and then here we have the one for the right channel. Now, as a matter of course, I just simply replace these resistors because I know it is a common issue and they are prone to failure. When I put it onto the multimeter and measured the resistance had already started to wander, so no longer was they now 47 Ks, they were sort of heading up to the mid-50s. What I've also done here is I've just put a circle as well around the speaker protection relay. Now these contacts become extremely oxidized and it leads to resistance, and that creates distortion when the amplifier is at low volume, or, as the owner reported, this intermittent loss of sound. So that relay is just replaced. If you choose not to replace it, you can remove the top cover and then maybe get in there and try and attempt to clean the contacts. And then here you can see the 47 k ohm resistors have been replaced. So this again is the left channel. And what I do is I just increase the wattage of those resistors just to provide some extra longevity. And then here on the right channel, the resistor has been replaced. And again, I put a circle around the speaker protection relay. This relay here is sealed, so that just provides the longevity with regard to future oxidization of any of the switching contacts. So once we've done the replacement of the RCA input socket, we've done all of the dry solder joints, we've done the cleaning of the soft clipping switch, replaced the 47 k ohm resistors and the speaker protection relay, and then also cleaned all of the user controls and switches with De-Oxit D5, including the headphone socket. The only final part then is to do the alignment. Now on this amplifier, which is very nice, you have two alignments which you need to perform, and the first one is to correct any high DC offset. Now this amplifier is really good when you're making the adjustment. Some amplifiers tend to be a little bit sort of tricky, and you make a small adjustment, then it takes a period of time, sometimes sort of 5 or 6 minutes, for the amplifier then to restabilize. What you find when you adjust in here for the NAD 304, when you make the adjustment, it stabilizes in 1 to 2 minutes. Now, the way in which you'll do these adjustments is, first off, if you're going to be adjusting the DC offset, then you need to connect your multimeter set to millivolts to the respective speaker terminals. Now, what you're looking for is a reading which is as close to 0 millivolts as possible, but here plus or minus 10 millivolts is your tolerance. And you'll do that also for the right channel. And then what you'll also be doing is to adjust the idle current. Now, on the amplifier main circuit board, you have 2 pins, and this is here on the left channel where they reference TP301 and TP303. And what you're doing is you're adjusting VR303 until you have a reading of 5.7 millivolts to 6.4 millivolts. So here we show you the DC offset adjustment and initial measurement, and you can see it's 2.58 millivolts. Now that's within the tolerance. It's within this 10 millivolt tolerance, but as I said, these amplifiers are really good to adjust. So here I make the adjustment, and you see we've got this down to 0.18 millivolts, which is excellent. And then what we do is we perform the same task again, and then here on the right hand channel, after adjustment, is down to 0.53 millivolts. Now, with regard to setting the idle current, here what you can see is the multimeter is connected to these test points. They're really, really close to some connections, i.e. resistors, and also there's a diode which is protruding up on one of the power resistors. What I would advise you to do is to depower the amplifier and then use these types of hook clips and then power the amp back up again and just wait for it to restabilize. Normally you need to leave the amplifier running for about 15 to 20 minutes in a stable environment for the amplifier to warm through. And then what I've done is I've just drawn a circle around 2 of the preset potentiometers. The one nearest to the black test lead is used for the DC offset, and then the one which you see near to the red lead is the one which you will be adjusting to set the idle current or the bias. And then here the initial measurement, we are low, so it's 4.18 millivolts. Not too bad. But after adjustment, you can see now we're back within the desired range, which is 5.91 millivolts. And then here we do the other channel, and you can see now we're at 6.16. Again, I'll leave the amplifier normally running for about an hour after this adjustment, and then I'll just do another measurement, but you don't find any issues with this amp with regard to drifting out of spec. And then here what we show you is all of the work complete. So you can see the amplifiers had a complete clean. All of the components which we referenced previously have been replaced. And then here you can see the failed components. The 47k ohm resistors, there's the speaker protection relay, and there's the damaged RCA input socket assembly. And what I've done is I've just drawn a circle around the broken pin. And this is not uncommon. Normally tends to happen is if the solder joints are dry and the owner maybe is connecting the leads, because you get that movement backwards and forwards over time, what will happen is it will just snap it off the circuit board. And then really the only final part of this repair and service is to give the amplifier a thorough clean, and then it goes on test for about 4 hours. And again, this amplifier really performed faultlessly. And it's a real pleasure to restore this amplifier back to how it was when it left the factory. And now it will deliver many, many years of high quality performance. So that sort of brings us to the end of this repair tutorial. So as always, I really appreciate you stopping by. And if you need any help, support or guidance, by all means, email audioamplifierservicing@aol.com. And I'll be more than happy to come back and provide you with any support that you may require. So, until the next time, I wish you all the very best. Cheers and bye-bye.